So let's go to clustered system. What is a clustered system? Like multi-processor system, but multiple system working together. It looked like the multi-processor system, but here multiple systems working together. Here it is not like only one unit is there and inside that we have multiple processors. No, it is working as a multi-processor, but it is not the one system we are talking about. Here we are talking about multiple systems. So if multiple system will be tightly coupled and they are working in a architecture, that particular architecture is called clustered architecture. Okay. And usually we use for in today's scenario where we are talking about reliability and fault tolerance, we use the clustered system. We use storage area network architecture into the clustered system. Okay. We have another architecture which is called network attached storage. Okay. And we have a storage area network. So let's take and find it out the difference between storage area network and network attached storage. Okay. And then we'll come here again we'll see what is there in the clustered system. Okay. So the first one that we are going to discuss is called network attached storage. Okay. As the name suggests, it is also called NAS architecture. As the name suggests, we have a storage area and this particular storage area has different storage devices. Let's say you have multiple hard drive available in the form of RAID. That is called redundant array of independent disk. You might have seen this particular type of concept in database management system, where we have redundant disks are there, and all these redundant disks are there in one system. So you can see this is your storage unit. Okay, you assume that this is your storage unit. Here we have some sort of controller which will give the power to this particular unit. And this particular unit is attached with some sort of access point. So assume that this is your access point, or you can say some sort of router by which this is attached. And with the help of router, many computing devices are attached. Let's say you have your desktop or the laptop which is attached. You might have some sort of what you can say a particular system which is attached, or you may have some sort of server that are attached. So all these devices are attached with the network, and this network is attached with the storage unit, and all these devices can access the storage whenever they want with the help of network. In this particular architecture, it is a good architecture for a personal use or for a small firm, where the fault tolerance will not be a problem. So what happen in fault tolerance? Let's say if this particular system fails some time, so what will happen is nobody can access this particular data. So the data will be cached, nobody can access it. Or if the network will be will not be here, so nobody can access it, right? Nobody can access the storage area or the storage unit. Now this was the problem, because here we doesn't have the concept of fault tolerant. Fault tolerance means can we uh, make another provision so that that fault can be rectified. So you can say this is not the robust system, means from the failure we cannot come back. Okay. So this was the disadvantage related to network attached storage. Now let's talk about storage area network. That is called SAN, storage area network. So what will happen in the storage area network, and what is the architecture of a storage area network? So here we have some sort of databases exist where we have multiple disks available. This is your storage area, and you assume that this is your power unit to this particular storage, right? Now all this storage is attached with some sort of switches. So we have the network devices. So we have some sort of switches. And we have some sort of servers. So this particular part, we have servers, switches, and actually storage. Now here, what is the architecture it has? It will be connected with all these switches, right? And it is also connected with that in the same form. You can say it is just like a mesh network. So what will happen here? These are the servers, right? These are all servers, and these servers can access the storage with the help of the networks, right? And if any of the system, let's say this storage fails, so what will happen is here we have some duplicate data also. So it is not like only one data is stored in one place. Here we have duplicate data which are stored in different places. So actually storage is more important than your switches and the servers, because servers will just serve whatever requests that come to it. Let's say a laptop has or a computing device has requested for one particular data. So it will go to the server will go and find it out where the data is. It will fetch it again, given back to the client, right? In this particular architecture. And what will happen is these data is stored in a duplicate form, in a redundant form. So here in one unit we have the concept of RAID. Here in different units we have the concept of RAID, redundant array of independent disks, where redundant data will be there. Means a copy of the data will be stored. Let's say we have a data A. So the copy of the data A dash will be stored in different storage devices. So if let's say one fails, so we have the copy in another storage device by which it will take the data. Let's say one switch fail, so from other switches it can be connected. If one server fails, so from different server it can be connected. So this architecture will be used in today's cluster computing. Okay, so I think you might understood the difference between network attached storage, that is called NAS, and SAN, which is called a storage area network. So this storage area network, because of the high clustered system, it provide a high availability services which survives failure. So as I told you, any type of failures can be survived by this architecture. Asymmetric cluster, what happened, and symmetric cluster, what happened. In asymmetric cluster, has one machine in host standby mode, in hot standby mode. In symmetric clustering, has multiple node running application monitoring each other. So in asymmetric clustering, what will happen is only one machine will serve, and one machine will have the responsibility to do all the serving thing to the client. But in asymmetric, all the machines should be active, and cumulatively they will do the work and get the data to the client. So that will happen in asymmetric, and each and every unit is running in your cluster architecture. Some cluster are for high performance computing. As I told you, we have in our institute high performance computing which exists, and it will follow storage area network architecture. Applications must be written to use parallelism. Parallelism should be there, means let's assume that I'll show you what do you mean by this parallelism. So to connect with this particular network, it should be a network device, right? Some sort of network device. So what will happen is every request from the client will go through this particular network device, and this network device will give the request to any of the server. Now what happened when we are using asymmetric? So network device will give, let's say, the request to only one server, let's say this server, to serve, and this server alone is responsible for serving the request to that particular client. Now what happened when we are using symmetric system architecture, in which the request will be divided parallelly, and the parallelism will be followed and given to different servers. And these servers, let's say the parallelism is, let's say it require let's say 30 something, so 30 unit of data. So what will happen is the network will divide the request to 10, 10, and 10, and all these server will serve. And because it is not the 30 that we are talking about here, we are talking about, let's say, 10 units. So it can serve very fast. So 10 unit can be fetched from the database and can be served very fast, and in that way they can be achieve parallelism. As well as if they want, let's say we have 3000 line of codes, and it need the server and the memory so that it will actually execute it as quick as possible. So it will use this particular architecture. Okay, so this 3000 code has been divided into 1000 code, depend upon that all these 1000 code are independent to each other by applying the parallelism. And these 1K, 1K, and 1K code has been given to the servers. Server, if they need the memory, it will use it. Otherwise, they will serve and they will give back the result to the client. So that will happen in symmetric architecture. In the asymmetric architecture, only one unit is active, and the parallelism would not be possible in symmetric clustering. Some have distributed lock manager to avoid conflict operation. So in some architecture, we have distributed lock manager, which will look for the conflict operation. Means, let's say if we have so many requests that are coming from different clients, and if they require the same data to be same, they all are working in the same data. So what will happen is there is this distributed lock manager which will look after the conflict request. So if only one shared data will be requested for the manipulation, it is not going to provide it. Okay, so it will look after the data also in a concurrent request or concurrent processing. So multiple processes, if it is processed by these servers or by these control units, so definitely it will look for the processes with the conflict. So if they are not, there is no conflict, so it will be bypass it, and the it will be served and given back the result.